Thank you for the introduction, John, and for the invitation to be here today. As John said, my name is Nicole Herman-Mercer. I'm a social scientist with the U.S. Geological Survey's Water Mission Area. I'm located in Denver, Colorado. And I'm going to present today with my colleague and the co-investigator on this project, Rachael Loehman. And Rachael is a research ecologist at the Alaska Science Center. So we're going to be talking about the Yukon-Kuskokwim Delta Berry Outlet Project, which was funded by the Western Alaska Landscape Conservation Cooperative. So first I wanted to just introduce the Yukon-Kuskokwim Delta for folks that aren't familiar with this region. The YK Delta is located in Western Alaska, where the Yukon and the Kuskokwim rivers empty into the Bering Sea. It is the largest intertidal wetland in North America, and the study that we're talking about today took place in 4 villages, in Kotlik, Amonic, Cooper Bay, which are all Yupik communities, and then the village of Chevak, which is a Chupik community. So I want to talk a little bit about why we care about berries. There are at least 29 plant species in the YK Delta that produce berries, and families in the YK Delta can pick more than 75 liters of berries annually. So berries are a really important subsistence resource, and they're also a cultural keystone species across Alaska, which means that they're not only fulfilling a nutritional role in communities, but also a cultural role, as they're an important food resource. They're also hugely important to the many migratory birds that nest in this region. The Yukon-Kuskokwim Delta is also a wildlife refuge, and birds eat the berries as well. So as climate changes impact berry resources and berry habitat, there's impacts to both the bird species as well as the human species in this region. So I'm going to let Rachael talk a little bit now about the information we have about vegetation in this region.
Great, thanks. Can everyone hear me?
Yep.
Yeah. Okay, great. So, yep, my name is Rachael Loehman, and I'm a research landscape ecologist, not a social scientist. And so I've been really fortunate, or Nicole and I think have both been fortunate to be able to pair our approaches here in the Delta and work together on this project. Part of the reason being that if you kind of look at the slide here and see this title, Long-Term Vegetation Monitoring on the YK Delta, well, first of all, I've put a star by long-term because this data that I'm showing here represents kind of the biggest data set that we have for the YK Delta. It was collected mostly by Thor Jorgensen over the years, over a period of about 20 years. So we have plots out there. They've been monitored episodically over this 20-year period. 20 years is not a very long time to try to understand dynamics of vegetation in space and time. And then in particular with this question of changes in berry resources, which we've heard about from people in communities, and there have been a few papers published on changes in berries in response to climate change. Not only do we not have a very long-term record, even with our best available ecological data sets, that record is weighed heavily toward the sedge and nearshore environments that provide really good bird food and bird habitat, not so much on the upland kind of permafrost underlain areas that support berry communities. And so, what this table is showing is basically all of the plots that we have where we've collected data over the years, or tourists collected data. We have those data summarized, but again, these permafrost plateau areas that are so important for supporting berry communities are fairly underrepresented in this data set. And so when I started working out on the Delta with ecological data, it quickly became apparent that if we were going to understand these dynamics of berries, not only do we need to augment this data set by adding new plots in these upland areas, but we also needed to be able to reach back further in time and understand how these really important upland areas have been changing. So next slide, Nicole. So here's just an example of one of our plots from 97 to 2007. The next time it was revisited to 2015. The most recent revisit, so it's kind of a typical upland area. So it's under this would be sort of a bubble-like plateau. It's underlain by permafrost, really important for supporting berry communities that aren't saline tolerant. So when big tides come in from the Bering Sea and move across this really low-lying delta, these areas are just high enough so they're not inundated by saltwater. So these berry communities can remain established and flourished and produce these resources. In '97, the community was dominated by berries. The light patches are various kinds of lichen. In 2007, that same spot, same vantage, looked about the same. There's an important feature in the background. You can see a little wetland area forming. That's actually a thermokarst where, because of warming and subsidence, a pool of water is forming. When we revisited the site in 2015, there's a really big influx of lichens replacing a lot of the berry plants, and then that thermokarst pool has become quite large and well established, and will probably over the next decade or so expand and completely kind of take over this upland area that will become a pond or a wetland. And so that's kind of what we're looking at here, is trying to understand how these dynamics are happening, what's driving the dynamics, and then the spatial and the temporal scales at which this is happening, so that we can relate that to a larger landscape picture of how resources are changing. So I guess next slide, Nicole, for you.
All right, thanks, Rachel. See, this is not cooperating. There we go. Okay, so as Rachel said, we have sort of a lack of data on berry resources in this region. So we really wanted to look to the folks that are living in these communities and collecting these resources to understand their long-term knowledge. So the objectives of this particular study were to document changes in berry resources as observed by the local experts, document the ecological drivers of change based on local knowledge of these experts, and then combine that local knowledge to with climate projections to forecast potential future changes in berry resources. So to do this, we combined a trichotomous choice survey, is what we're calling it, with a participatory mapping exercise in these 4 communities. So what that means is that we administered a survey in person where we read statements concerning different berries that participants were then asked to agree with or disagree with or state if they did not know the answer. So they were given 3 choices. Then we asked the participants to draw the location where they pick berries on a sheet of mylar that we had overlaid on top of a topographic map. So we used a purposive sampling strategy targeting community experts in these villages, and we defined experts as community members that had lived in their community for 10 years or more. They'd been berry picking in that community consistently for 10 years or more. And we had help from our project partners and the tribal councils to find these community experts. So, and then we also asked community members before they participated to make sure that they qualified as experts in this case. So a total of 53 people responded to the survey and created a total of 48 maps. We had 1 respondent that didn't complete the survey and was removed from the final analysis that I'll get into next. And then the difference there in the number of respondents versus the maps created is due to husbands and wives and friends and sisters in some cases creating maps together as they go berry picking together, but then responding to the surveys individually. So of the 52 participants we had, 34 were female, 18 were male, and then the average age of our respondents was 55, ranged from 30 to 79. And on average, the respondents had lived in their village for 46 years with a maximum of 75. And then the average number of years our respondents had been picking berries was 43 with a minimum of 10 to meet that project requirement and a maximum of 79 years. So you can see the demographics here for the participation requirements and age, and then the breakdown of respondents from each village. So there was a lot of experience in berry picking represented in our sample. So we asked questions or read statements about 5 different berry species: salmon berries, red berries, blackberries, cranberries, and blueberries. And before we began reading these statements about the berries, we showed these pictures to ensure that we were talking about the same berry. Some of you may note that salmonberry is referred to as cloudberry in other locations. So we wanted to make sure that we were talking about the same berry species when we did these surveys. And then we also asked participants if there was a name in their community that the berry was known by. So the first statement that we read for each berry was, "This is an important berry in my household." And then this graph shows the responses for that statement, with 100% of respondents agreeing that salmon berries are important in their household. And then blackberries being identified by 98% and blueberries by 90% of respondents as being important in their household. Cranberries and red berries were less important to community members that we talked to, and therefore the sample size for the responses on those berries is much smaller. So we're just going to focus on salmon berries, blueberries, and blackberries. So this is an example of a statement that was read to sort of get at these long-term observations. These berries ripen earlier than they did 10 years ago. And then there's the other statements that follow along this observation category on this graph. So for observations, these berries ripen 10 years earlier than they did 10 years ago was the highest frequency of yes responses, with 81% for salmon berries. The other changes that more than 50% of respondents agreed that they were observing was a change in the landscape at harvesting locations, more variable abundance from year to year. So some years a lot of berries, and then other years fewer berries, with more variability than people remembered than in the past. Blueberries and blackberries also were reported to be ripening earlier, and changing the location that they harvest for all three of these berries. Blackberries and blueberries were reported as being less abundant than 10 years ago, also by more than 50% of respondents. And then here's an example of a statement that was read concerning this local ecological knowledge. So having a small amount of snow is associated with fewer berries the following summer. So we asked, or we read a few statements about potential ecological drivers, and the ones that were really identified as being important that the majority of folks agreed with was low winter snowpack and high summer temperatures having a negative impact on berry resources. There was also some agreement that ATV trails are impacting habitat for salmon berries and blackberries, you can see here, but the ones that really stood out here are the hot summer temperatures and the low winter snowpack. So now I'm going to turn it back over to Rachel. Oh, no, I'm not. First, I'm going to talk about these maps. So then we asked participants to map the locations that they are harvesting berries, and we asked them a couple of questions concerning the locations that they harvest berries. So first, where are you currently harvesting? Has the location where you're harvesting these berries changed? When did that location change? And then why did your location change? So if participants indicated that they were having to change their harvesting location, we asked them to also draw the location that they previously harvested. So these are the maps created by participants from all 4 communities for blackberries, salmon berries, and blueberries, showing both the past harvesting locations and the current harvesting locations. So now I'm going to turn it over to Rachel to talk about how we combine this ecological knowledge with climate projections.
Okay, thank you, Nicole. So just going back quickly to the format of the questions and the mapping components of the project. I mean, what this really allowed us to do is, first of all, extend our data record. You think about what I said, having 20 years of vegetation data in limited spots for a limited kind of subset of the ecological systems in the Delta. Now we have access, potentially, 80, 60, or 40 years, depending on who we've talked to, of changes happening on the landscape. So that became really important. We also were able to focus in on specific berries that are of interest in terms of subsistence, which is important because not all berries respond the same to different kinds of landscape changes. Some plants have higher tolerance for saltwater inundation. So when we get big storm surges that are coming in, which are happening more frequently at a higher magnitude because there's less pack ice out in the Bering Sea, some berries are able to kind of withstand that inundation for a bit, whereas others don't make it at all. There's similar kind of sensitivities to different climate drivers. So identifying those particular berries to focus in on has been really important. And then we asked people about drivers of change. So what of all of the, large suite of potential climate drivers, and then the seasonality of those drivers, and then these other kinds of landscape changes, erosion, flooding, ATV trails, what of those drivers have been observed to be significant. So that lets us relate these patterns of change two kinds of data that we have available to make projections. And so what we're going to show here are just some climate data that are available. These are 1 kilometer data from basically a continental scale downscaling project. And so I just took different variables, in this case, that were related to 3 of the questions we asked. So if we look at the issue of earlier ripening, so that's one of the observations that has been made in these 4 communities, is that berries are ripening earlier. So the top panel shows the average normal temperatures by Julian day for the onset of the frost-free period, and then we have the same information with 1 climate scenario or 1 emission scenario for the 2050s and the 2080s. And so the colors mean basically the start date of the onset of spring is the way you could think about it. And so that would be related to when these berries start ripening. And so the yellows are a later period, and then the reds are basically spring occurring earlier. And so over on the box plot, I made kind of a little cheat sheet for us to relate Julian days to months of the year. But basically what we see is that the normals would be for an onset of spring around late May. In the 2050s, we're looking at early May ripening date, and then in the 2080s, late April. So if you think about how that trend relates to what people have been seeing, well, we're out of the normals period. And so we can get kind of a spatial view as well as a projection of how this trend that's been observed might continue. So next slide, Nicole. Okay, so another observation, more dead plants, more dead berry plants out there on the landscape. And so one of the drivers of mortality in these berry plants can be decreased availability of moisture, which can happen if there's less rainfall. It can also happen with higher temperatures that cause these plants to transpire more of their water as you have this drying happening in the soils. And so again, if we think about this period of normals, or the average climate for a 30-year period compared to projections, basically what we see is that the summer, which would be June to August temperatures, are increasing with our climate projections, or these climate models, over these 2 future periods as compared to the normal period. And so this observation of more dead plants not only is supported by the fact that summer temperatures are getting warmer, but then we have these climate data that suggest that trend is going to continue. And then we have one more. So one of the strongest kind of outcomes of the survey in terms of drivers has been the relationship of fewer berries to decreased winter snowpack. And the reason for that is that some of the berries that we've been looking at set their fruit buds the year before, and then those are basically immature on the plants, and they make it through the winter. And then as soon as the growing season starts the next spring, those berries can start maturing. If there's a deep snowpack, those really fragile fruit buds are insulated by the snow from cold temperatures, cold winds that exist all winter long. If there's not a lot of snow, and what snow there is, tends to be moved across the landscape by high winds, then those berries are usually frost killed, and so the next year there are going to be fewer fruit buds on the berry plants to ripen into mature berries during the picking time the subsequent year. And so that snowfall is, again, one of the strongest drivers that emerged from the survey, and is also just from other studies that have been published in polar regions, one of the really important variables that determine the success of berries the subsequent year. And so the normals for this region, you see this sort of dark blue color in some areas, like by Hooper, we've got this kind of pink color, so a higher snowpack. And then as we continue forward into the future, this projected climate, we see lower and lower snowpacks. And not only in these climate models is the median amount of precipitation falling as snow getting is less each year, or is less each period, we also have kind of decreased variability. And so what that's saying is that, the years in which there's low snowpack just become more and more and more common. And so that is not a good thing for the future of these berries. So next slide. Okay, so that brings us to how we're going to continue on the ecological side in the future. And so one of our I think big contributions in this project has been on the ecological side, to establish what we're calling wild sites, water ice landscape dynamic sites. These are long-term ecological installations. You could think of them kind of like the National Science Foundation NEON sites, Earth observing sites. The intention is to have these out on the landscape to monitor conditions, every year or every season, depending on the variable of interest, to provide, data in real time as possible or annually, and to basically set these up as established monitoring areas where we can start to get an idea of landscape, atmospheric, terrestrial, vegetation, wildlife dynamics, all co-located, so that we have the data that we need to build forecast models and to understand the complex interactions of atmospheric and terrestrial dynamics all in the same place. So these are right now near two villages, one in Kotlik and one in Chevak. They're co-located with permafrost monitoring or active layer network monitoring sites, and Nicole could talk more about that. We established them in collaboration with EPA, IGAP, employees at villages. And so we have that partnership going. And the core of these wild sites is a really sort of high-tech, comprehensive weather station that has a satellite uplink. So we have real-time data that are available. The data are summarized and available on a website, as more digestible data streams. And then this year we established vegetation transects, and that's kind of what the schematic shows. Vegetation transects at the site where along belt transects we monitor vegetation or species composition, and then also have these special kind of subplots where we're taking a look at the berry communities in those subplots. We'll do winter snowfall, snowpack, snow water equivalent measurements. We have surface elevations and permafrost depths. We have the permafrost monitoring at the ALN sites. And we have the ability to add different kinds of investigations here. For example, things like snow exclosures, pollinator studies. And so this is really providing, again, kind of a synthetic source for all of the data that matter to modeling things like like plant species dynamics or other things into the future. So I think I just have one more slide that shows a picture of one of the sites. So this is one of our collaborators, Victor at Kotlik, standing in front of the weather station that we put up there. And then we have some pictures from our field work this summer. So again, you have the weather station in the background. We're taking surface elevations, doing permafrost monitoring, and then this summer collecting vegetation. And then this winter we'll be back to do the snowpack measurements, and then we'll return twice a year to do to collect those data, plus additional projects that we established there. And then the goal is to establish two more wild sites in the coming year, and then expand the network as we can with continued funding. And that's all I got for that.
Okay. Thanks, Rachel. Yeah, so that's it. I want to acknowledge all of the folks that helped make this project possible, and I'm going to throw Ryan and Cynthia under the bus because they are both on the call. So feel free to ask Cynthia from Chevak or Ryan some more questions about this project, as they both helped us do the mapping and the surveying. Thank you.
All right, thanks Nicole and Rachel very much. Any questions for our presenters?
Yeah, this is Simon Stevenson from NSF. Can you hear me okay?
Yeah.
Yeah, so I'm interested in the wild sites, the two, and you've got plans to expand. Are there other wild sites in Alaska, or is this something relatively new and focused?
So this is new. Do you want to talk? Go ahead, Rachel. You speak to that.
Okay, yeah. So we established these as part of this project. So we had some money from the BIA for a climate change project in Chevak, and then we had a collaborator from the Forest Service who was able to help us out with the installation or lead the installation, and then supply some of the materials. And then we had money from the Western Alaska LCC. So this is completely a grassroots effort on our part. We wanted to be able to, so my observation from doing the data collection at the for the long-term monitoring network was just that because we have fairly poor availability of weather data in the Delta, and often our monitoring sites are far away from weather stations, and the weather can be highly variable across space. We wanted to be able to measure all of the important variables, particularly things like snowpack and local temperatures that relate to vegetation dynamics in the same place. And so this is our effort to put these sites in. And basically we're putting them in as we have funds, one site at a time.
Okay, thanks. They look very interesting. So congratulations to have done so much.
Thank you.
Such what sounds like a pretty modest level of resources.
Yeah, thanks. Well, and I should say that we're, one of our hopes is that we can bring in others who are interested in benefiting from the co-location of all this monitoring data and monitoring potential. So, for people who are interested in lichen dynamics or, gas exchange or whatever, these sites provide an opportunity to bring those people in, and again, in sort of a grassroots effort, develop something like NEON, something really comprehensive that we can invest in. And one of the things that we don't want to do with these sites is put them in, extract some data for a few years and forget about them, both because it leaves a bunch of junk out in the tundra that doesn't look good and doesn't benefit anyone, and also because it's really going to take a lot of effort over a number of years to understand the complexities of everything that's happening out there. So whatever we can do to invest in these and keep them going and expand our network, I think we're happy to do.
Thank you.
All right, thanks. Well, in the interest of time, I'd like to give Liliana some time to get her presentation started. So if you have any additional questions, if you can hold those to the end. But for now, I'd like to introduce Liliana Naves with the Alaska Department of Fish and Game, who's also going to be talking about work out on the Yukon-Kuskokwim Delta. So Lily.
Thank you, John, for inviting for this presentation and for having me at the meeting. I work for the Division of Subsistence of the Alaska Department of Fish and Game, and I coordinate the Harvest Assessment Program of the Alaska Migratory Bird Management Council. And I'll talk a little bit more of that during the presentation. Should I go ahead and put on share mode here?
Yeah, that would be great.
Okay. My co-authors in this study were Jackie Keating, she also works for the Division of Subsistence, and also Dan Ruthroff and Lee Tibbetts that are with the Alaska Science Center with the U.S. Geological Service. We're all based in Anchorage. This study, So this study is about the shorebird subsistence harvest and the indigenous knowledge in Alaska. And it was conducted in the context of the Harvest Assessment Program of the Alaska Migratory Bird Management Council. So the council has three partners: the U.S. Fish and Wildlife Service, the Alaska Department of Fish and Game, and the Native Caucus. which is composed by representatives of regions across Alaska. The Harvest Assessment Program has two main components. We conduct annual bird subsistence harvest surveys across the state, and we also do harvest research as dedicated projects to fulfill priority information needs. The priority information need here related to the population status of shorebirds. Shorebird populations have been in decline because of habitat loss, climate change, human disturbance, harvest, and other factors that are occurring at migration, wintering, and the breeding grounds. The populations of shorebirds that are long-distance migrants and that breed in North America have declined by about 50% since the mid-70s. So I have received recurrent calls about shorebird harvest data, and there have been requests for consolidate harvest information and also increased communication with subsistence users. So this is a topic that it can be sensitive to communities when working with communities, so it's a little bit of a different approach. Shorebirds are a small proportion of the total subsistence harvest of migratory birds in Alaska. It's less than 1% of the total harvest, but some species included are of conservation concern. So the objectives of this study were to consolidate data available on shorebird subsistence harvest for all regions of Alaska, and to document the local and traditional knowledge to give context to the harvest numbers, and also to better understand the importance of shorebirds as food and cultural resources for Alaska subsistence communities. The harvest estimates were based on data set that compiled surveys conducted between 1990 and 2015. This data came primarily from two large databases: the Community Subsistence Information System that compiles research conducted by the Division of Subsistence, and also the Harvest Assessment Program of the NBCC. And we also use data from other research conducted by Native organizations, by academia, and other research entities. So the harvest estimates are there in these two bar plots. On the left side, we have shorebird harvest estimates, and on the right side, harvest estimates for eggs. On the horizontal X are regions in Alaska, and the colors in the bars are categories of shorebirds. So the data are not available at the species level, and these are the species that we're able to work with. The estimated harvest of shorebirds in Alaska is about 2,800 birds per year. 15% of this harvest happens in spring, 44% in summer, and 41% in fall, winter. Important component of this harvest are godwits, that's the yellow part of the bar, and this is about 1,100 birds per year. This harvest is geographically concentrated in the south coast of the Yukon-Kuskokwim Delta. The shorebird egg harvest is estimated at about 4,700 eggs per year, and this harvest is more distributed among regions, including the Bering Strait, Norton Sound, and other parts of the YK Delta. The indigenous knowledge component focus, there we're dealing with Alaska-wide, and here when you move to indigenous knowledge component, we focus on the Yupik culture of the Yukon-Kuskokwim Delta, because this area is very important as shorebird habitat, and also because you know from the available data that a good part of the harvest comes from there. Participation in interviews was voluntary for communities and individuals. We asked the tribal councils to indicate people that are particularly knowledgeable about birds as potential interview respondents. And we conducted 72 interviews in 5 communities in Alaska, indicated by the red stars there. That's Hooper Bay, Tuksuk Bay, Quinnahock, Platinum, and Bethel. In the interviews, we included men and women, elders, and active harvesters. So we used 3 activities to collect data on ethnotaxonomy. This means how people name birds and how they lump and split them in categories. So first, we asked people to name to say shorebird names that first came in their mind, and that was a quick snapshot. Then next, we showed people pictures and cards, and we asked them to name the birds. We also played the recordings of bird sounds and asked them to name the birds. So I have a few examples here of those. Oops. And I have to, let's see if I can. They're not playing from the Bluetooth here. Well, let's move on, and I'll try to make things work later. So after this, we had a third ethnotaxonomy activity where we showed people pictures with names that you found in the literature, and you asked them to indicate the names that they were familiar with. And the process was to progressively provide more information to help people remember birds and their names. I'll not enter in details about the analysis of the ethnotaxonomy data, but I can provide information. So we identified 24 Yupik shorebird ethnotaxonomic categories. And those are represented in the diagram there with the Yupik names. So the shorebirds are known mostly by specialists. And the respondents were most familiar with Yupik shorebird names, and they often didn't know or did not use English names. At least 13 categories included more than one species, and at least 8 categories had onomatopoeic names. This means names that imitate sounds. And there were 7 most salient categories, which are those highlighted in yellow and represented in the pictures. Next, I would like to show some quotes from interviews. And I have audio recordings if I can make them work, but the first one is a little longer, so I'll read this one and let's see if you can play the other ones. So when I was growing up, I used bow and arrow and slingshot to hunt shorebirds. Those were my weapons, my hunting tools. It teaches a child how to stalk a bird without spooking it, try to get as close to it as possible, and that's the challenge. It teaches you patience to get to the bird, how to crawl or stoop down or hide behind a knoll. It teaches those skills. Another quote, let's see if I can play this one.
What's fascinating to me is everything is connected to each other, and there's, even if there's one species that we see that's thriving, they're depending on the species, and that species is depending on another, and so in turn we're depending on that species too, and many other species. So we're all connected in a way to where we try to respect that animal. So that respect is some of the things we do. So it'll return more or kind of positive thing to do, like traditional or cultural things that we follow by. When the numbers were going down, I have been hunting for a while. And I haven't seen like hardly berry seed in a while.
Why don't you hunt them anymore?
The numbers are going down, and I don't want them to go extinct. I always wait till they get more. Yeah.
So shorebirds and their eggs are not a primary food source, and they're used only for food. Egg harvesting is enjoyed by families and children. In the past, shorebirds were harvested with bow and arrow, slingshot, and other creative means. Nowadays, adults use a shotgun to harvest shorebirds for an occasional meal, especially in fall when the birds are fat. And the children harvest shorebirds with BB guns as part of learning hunting skills. Shorebirds have been harvested in times of food shortage and as emergency meals. So for instance, when people get stranded or their boat breaks. So they have a cultural and emotional value attached to them, especially among the older generations. And the ability of relying on non-primary food resources is part of a complex food security strategies in remote communities in Alaska. When asked about the cultural importance of shorebirds and concerns, respondents said that the shorebirds and other birds are a joyful part of the landscape and especially the soundscape. In the spring, when birds arrive and the vocalizations and the breeding displays mark the end of the long winter. Some respondents related with the birds as aware or sentient beings. And cultural items related to shorebirds included stories, songs, beliefs, place names, and a wooden mask, such as this one there in the picture. But the shorebirds were not as prominent in Yupik culture as other birds. The older generations associate the shorebirds with a time when people were in closer contact with nature and with their traditions, and they are concerned about loss of culture and language. And many respondents reported that numbers of shorebirds are much reduced, but they are often unsure about the causes. Some considerations about the harvest, monitoring, and management. So shorebirds included many species that look alike. The local ethnotaxonomies differ from Western taxonomy, and the harvest data are unavailable at species level. So shorebirds are not commonly harvested. They are harvested in relatively low numbers. So the harvest estimates have wide confidence intervals. This means that they are not very accurate. But harvest data have been regularly collected in Alaska, unlike anywhere else in the world. So what you learn here in terms of harvest monitoring and manageable is useful to other places along with the migratory flyways. There are mismatches between harvest practices and regulations, and also because of the species identification issues, it is likely that at this point in time, restrictive harvest regulations are at the species level are impractical, and the harvest management must employ outreach and education to engage harvest and conservation efforts. So shorebirds represent connections with the environment and the subsistence traditional way of life. And these connections are key for the well-being of the communities and also for community-based conservation efforts. So we put forth some recommendations, and they are kind of really broad scope, and they are more specific items that follow within each of these categories. But for instance, we recommend to support the transmission of knowledge and the language and interactions between elders and youth, to increase awareness about the species identification, ecology, and conservation, and to increase interaction of indigenous stakeholders with biologists, managers, and conservationists. Also, support local efforts that benefit shorebirds and their environments. For instance, management of ATV traffic that was this topic appeared in interviews in all the communities. And the bottom line is that the need to collaboratively develop the conservation approaches that are inclusive of traditional uses and the cultural importance of shorebirds. And I would like to thank all the people that worked with us and participated in this study. the people that participated in the indigenous knowledge interviews, the tribal councils, the local research assistants, the researchers and local surveyors that worked in the bird harvest surveys that used it for the harvest estimates, and the Jinfo and Fiona for their continuous assistance with the social science part of the research, and to Rebecca Nayamin that helped with everything related to the Yupik language in this project.
Great, thanks so much, Lily. Are there any questions for Lily at this time? Well, if not, I would like to ask a question of all of our presenters today, and that's about the method of using the survey and then the responses to sort of help frame some of the research or understand the research that's being done. What sort of feedback have you had from people that have done the surveys when they see sort of the final data from all the different communities? And do they feel like that's a good approach to do additional research, or do they think that that's more of a baseline way to start and then do other kinds of collaborative work to go forward? So maybe Nicole and Rachel, would you want to take that first?
Sure. So this is one of the first times that I've actually done a specific survey in a project like this. I prefer to do, broader interview type stuff than sort of pin people down to specific responses. But I do think that it was useful in helping us define how to move the research forward and what things we should be looking at. And I felt like it was the appropriate method for this particular project to help identify the ecological drivers and the observations in a more defined way than, perhaps a qualitative interview could have. I wonder, I kind of would like Cynthia to comment on this, because Cynthia she helped us do the surveys, and she also is she's in Chevak. So I don't know, she may have a good perspective on how the communities are, how receptive they are to the surveys and then the results. I don't know if Cynthia wants to say anything or not, though.
I'm sorry, but I missed the question or comment.
Do you want to repeat? Oh, go ahead, John.
Yeah, hi, Cynthia. This is John. I was just curious sort of what you or others feel about the survey sort of method for understanding, your community's opinions or thoughts on ideas, research ideas, and if that's a useful way to start a collaborative project with scientists or with other people.
I don't know. I can't say how the others feel regarding this. It's kind of like hard to tell with how our ground is, to be able to figure out how the berries, like how in the end will we fix it if we have to do something like that.
Okay, thanks so much. And Lily, do you have any thoughts on that, or did you have any? Did you hear any feedback from people when you were conducting surveys or asking questions about that?
Well, we developed an interview instrument, and you had the biologists and the anthropologists in the team, and then we fine-tuned the interview methods with pilot interviews with subsistence users, and through partnerships in the AMBCC, we're able to get feedback on what we're doing along with the process. And also along with the process, I interacted with the Waterfall Conservation Council of the YK Delta. So there are means of getting feedback along the way, and it's possible to adjust course. So I think that, yeah, you do the best that you can to start somewhere and make adjustments as needed.
Okay, great. Thanks for that information, that feedback on how that went. Any other questions out there on the discussion today?
I have a question. Hi, this is Amina.
Yeah, please.
Great talks. I was wondering about the first study you had, the discrepancy between, I guess, I don't know how you call it, between the women. You had a lot more women responding to the survey. Is this because this is a gendered activity, or is it just happened that way? And if it is a gendered activity, did you at least did you hear feedback as to how this affected other aspects of their lives as they had to move around, look for other patches of wild berries too?
So yes, thank you for that question. So there were more women than men, and that is because it is a gendered activity. It's, traditionally been women that are picking the berries. I think that presently that's not as much of a gendered activity, that men are going with their wives or with their sisters or whomever it is to pick berries. And oftentimes when we were doing the mapping, men had sort of a better idea of the locations that they were going to, but they were going with their wives. So it was nice to have husbands and wives participating together in that regard. And then the one survey that I mentioned that ended up not making it to the final analysis was with an elder, a male elder, that started taking the survey and then said, "What are you doing? You should be talking to women. Why am I doing this survey?" And he just sort of stopped participating, which was fine. But that is why there's the discrepancy. And in regards to impact on lives and having to move around to look for berries more, that's something that, because of the constraints of it being a survey with specific choices, we weren't really able to dig into. So we're hoping that moving forward with expanding these wild sites and hopefully expanding the survey to other locations of the YK Delta, to other communities, that we can also do more semi-structured interview type stuff to understand those a little bit better, those questions.
Any other questions out there?